In this video, we're going to talk about rational functions and their behavior. Rational functions are just functions in the form of a fraction where both the top and the bottom are polynomials. To describe this behavior, we're going to use what's called arrow notation. And the way we write it is like this. Right? So we write x arrow A or y arrow B to describe how the x and y values change. Usually we use the x values to tell where to look on the graph, and we use the y values to describe how the graph is changing. One thing to notice is that when we write x arrow A, it means that x is approaching this value, but it's not necessarily equal to the value. And this becomes important when we talk about the holes in a graph. Similarly, when we write y arrow B, y is approaching some value, but it's not necessarily equal to that value. Because we want to describe exactly where to look on the graph, we use the superscript notation here, a plus or a minus, to tell if we want to look to the right of some area or to the left of some area. Right? So you don't want to confuse this with positive and negative. So when it's in the superscript like this, it means to the right and to the left. So if we write something like this, what it means is that x is approaching positive 3 from the left. And if we write it like this, it means x is approaching negative 2 from the right. An important feature of rational functions we're going to look for are what's called asymptotes, both vertical and horizontal asymptotes. So asymptotes are imaginary lines that the graph approaches but doesn't quite reach. Right, so we can look at some examples at these graphs below. In this first example here, the function 1 over x, so the graph looks like this and has both a vertical and a horizontal asymptote. The vertical asymptote is at x equals 0 here, and at y equals 0 here. Now the function here is 1 over x squared. The function looks different, but has the same vertical and horizontal asymptotes. Right, so the vertical asymptote at x equals 0 and a horizontal asymptote at y equals 0. So you can see that for the horizontal asymptote y equals 0, the graph is getting close to it, but doesn't quite touch it. Same here, you can see the graph is getting closer to it, but it doesn't quite touch it. And also for the vertical asymptote, the graph on the left is getting close to it and going upwards, and the graph also on the right here is getting close to it and going upwards. So we're going to try to describe this behavior in a little bit. And then finally, the function x plus 1 over x minus 2 looks kind of like this, and has a vertical asymptote at x equals 2 and at y equals 1.